welcome. And so I wanted to return back to all of our graphs and identify domain and range. Take a look at domain and range. All right, so this was the first graph that we did in this series of podcasts. All right, so I already labeled the red graph, the original function, f of x equals negative 5x plus 2. Right? Let's use, I didn't write the equation for the inverse. Let's use point slope. All right, so for our inverse, we've got, let's use 2, 0. Y minus 0 equals negative 1/5 x minus 2, right? Just using point slope. Y minus y1 equals m times x minus x1. Of course, we don't need the 0. So we have y equals negative 1/5 x minus 2. All right, and we can just leave it like that. We don't have to distribute, right? We can write it in point slope. So our inverse, we have f inverse is negative 1/5 times x minus 2. All right, so let's do the domain of our original function. All right, so linear function. There's no number I can't multiply negative 5 by and add 2 to. And notice that our the linear function, our f of x there, it should have arrows on it. It doesn't. There we go. So linear functions, arrows on both ends, is going to keep increasing horizontally and vertically forever and ever. So its domain, negative infinity to infinity, and so is its range. Since the inverse is also a linear function, its domain is also negative infinity to infinity. Because if you switch negative infinity to infinity with negative infinity to infinity, you get the same thing again. All right? So here, domain and range, all real numbers for both graphs, f of x and f inverse. Let's take a look at the next one that we have lots and lots of writing on. All right, so we did label the f of x, but we did not label the inverse, and we're not going to, we labeled it, but we didn't write the name of the function, and we're not going to either. Later on. All right, so let's identify the domain and range of f of x, and we know how to do that because we worked a long time with square root functions. So f of x, its domain, right? So its domain is not all real numbers, right? Our first x value is at negative 1. We do go through negative 1. And then it continues on forever in the other direction. So negative 1 to infinity. Our range, the lowest y value is 1, right? That's our first y value. So our range is going to be 1 to infinity. Let's do the same thing, domain and range, but now for the inverse. All right, that's supposed to be a negative 1, and it doesn't look like that. There we go. All right, so domain. All right, so now if we're looking at the x values, right, there's our first x value. So 1 does go through 1. That was one of our points. Right, 1, negative 1. So 1 to infinity is our domain. Let me get rid of the little line I just put in there. How about the range? Well, lowest y value is right there. So our range is negative 1 to infinity. Do you see a relationship between those? Let's see, f of x, domain negative infinity to, negative 1 to infinity, range 1 to infinity. F inverse, domain 1 to infinity, range negative 1 to infinity. Let's do another one. All right, so let's look here. All right, so this was, it's okay. It's not my best graph on an inverse. It's polynomial ones can be tricky. I don't know, it's just me. I just can't get the right curve. Maybe if I look sideways. I think I said that before in the video. I need to go kind of out. And I think it's a little better. You're probably better at it than I am. Let's find our domain and range, however. All right, so let's look at our, and by the way, this is going to continue. Both of these graphs will continue forever and ever and ever and ever. All right, so our f of x, and that was this one here. All right, so f of x, domain. All right, it's a polynomial function, right? It's going out, right, in both directions, right, eventually. I think it's a little bit skinny, but yes, it will go out in all directions. By the way, we can tell, so let's think about what kind of polynomial it is. It is a polynomial. It's a cubic. This one happens to be a cubic function, right? So f of x is cubic. And we know the domain of a cubic function, an odd degree, is going to be negative infinity to infinity, and so will the range. Right? And we can see we got arrows going up. How about our inverse? Well, you can definitely see it's going out, right? It's not stopping. It's going to keep on going. There's no stopping it. So, oops. Let me just rewrite that. There we go. So our inverse domain, also all real numbers, and our range is all real numbers. Right? Kind of like our linear graph. Let's look at the next one, domain and range. By the way, you might notice that f prime of x looks like some familiar graph. That's all I'll say. How about here? All right. So, domain for f of x. All right, well, that is a parabola. That's clearly a parabola. Matter of fact, the equation for our function, right, is, so it's a parabola. It is dilated. Right? So normally, right, we think of the standard shape. Right? So let's pretend that's 0, 0. Then we'd have negative 1, 1, and we'd have 1, 1. Right? And they'd maintain that growth, and then we'd have 2, 1, 2, 3, 4, right, on that side, right, to maintain our little parabola there. Right? So this would be our standard parabola if I connect the points. That's better. But that's not really the origin. We're just kind of give you the idea of the shape. So this is a dilated graph. In a future lesson, we'll talk about dilating and reflecting and translating using the same technique we used for square root functions to graph quadratic functions. But that's not what we're going to be doing right now. So I just wanted to help you see what the equation is for our parabola. And so when I write it down, it'll make some bit of sense. Right? So it is dilated by a factor of 3. So it is 3x. It's not shifted horizontally at all. Right? Its vertex is at 0, negative 3, but it's been shifted down 3. So this is f of x equals 3x minus 3. That's what that graph happens to be. Parabola domain is all real numbers, but not the range, right? Because it turns around at the vertex, right? So our range is negative 3 to infinity, and it does go through negative 3. How about f prime, or excuse me, f inverse? Right? We won't worry about that equation. How about its domain and range? Right? So now the domain doesn't keep on going, right? It turned around. Stops right there. Right? So that's negative 3. So its domain is negative 3 to infinity. But it's going to keep going up, right? It's got arrows at the end. It's going to keep, I mean, it looks like it's, it's going to still flat like that because it takes a while, but it will eventually just keep on growing and growing and growing and growing. Okay? So our range is negative infinity to infinity. See a relationship there. I think that was our last graph. So hopefully, it's not so obvious with the linear and the cubic, but hopefully between this graph and this graph, you see a relationship between domain and range for the original function and for f inverse. And I'll ask you in class what that relationship is. Thanks for watching, and bye for now.